Project 142 is slow disco ball. I'm including the speaker, the press switch, and obviously the disco motor. Now, I wish I could do this, but since I can't, I'm just going to have to run the motor without the disco cover and shaft. I will turn on the slide switch, and the disco motor spins. I am going to push and release the press switch. And although it spins, it does not spin as fast as it does in Project 10. If you remember that, if you've seen that project, you might better understand the concept of Project 142. The resistance of the speaker limits the voltage that is traveling to the disco motor, so it will not be as fast, and it needs more power to get started than to get spinning. I guess you could say this when you are starting like a pull string piece of equipment such as a lawnmower. It may take a lot of energy to get the machine started, but once it's running, then you're usually good until you cut off the power supply. It spins slightly faster after you push and release the press switch. When you hold the button down, it spins at full speed because the speaker is bypassed. Release it and the motor will slow down because now the speaker is limiting the current again. Project 143 is slower disco ball. Using the preceding circuit, I replaced the speaker with the red LED. We will turn on the slide switch, and the motor does not spin. Now when I push the press switch, the motor will spin, but very, very slowly. Why doesn't it spin at all when you first turn on the main switch? That is because the red LED is a much better resistor than the speaker. It limits current a lot better, so less power will get to the disco motor. Pushing the press switch will give the motor a boost so that it spins very slowly, but that is all the power that it can receive. Project 144 is Selector with disco motor LEDs. For this project, I added the S8 module, and after we turn on the slide switch, nothing will happen. The objective is to push the buttons on the S8 module and see what happens. You'll notice that the LEDs on the disco motor light up. They may be hard to see, but they come on. And they may look bright, but they're not going to be as bright as they are when you push the press switch right here. You can probably tell that they're a lot brighter than when you first hit the buttons on the S8 module. All the buttons do the same, so there's no difference between pushing either the A, B, or C buttons. The reason why the LEDs may not be as bright when you push the buttons on the disco motor as compared to pushing the press switch is because the buttons on the S8 module actually have some resistance, so meaning that they limit current a little bit, so the LEDs may not receive as much power as they would if you simply hold down the S2 switch. This button is not as does not resist current as well. 145 is Selector with disco ball. Notice the question mark at the end of the project name. What we will do is turn on the slide switch, which it's already on, and then we will push buttons on the S8 module. And the Disco motor will light up and spin, but you may notice that it is not very bright and does not spin too fast. I pushed all 3 buttons on the S8 module at least twice. Now I'm going to push the S2 switch. Now the disco motor goes at full speed and the shaft and the LEDs are at full brightness. But using the S8 module alone will not make the motor spin at full speed and light up completely. And like with the previous project, the buttons on the S8 module have more electrical resistance than the press switch. Now, in order to help the selector, we're going to move over to the next project. Project 146 is Selector with Disco Ball /NPN. This circuit is using the NPN transistor, and if you watch the previous project, you'll learn that the selector with the buttons will need help on spinning the disco motor. So the slide switch is on, and this is when the NPN transistor comes in handy. We're going to push one of the buttons, and now the S8 module, the disco motor, runs at full speed, and its lights are at full brightness. I'm going to push all 3 buttons. And I am not using the press switch in this project, unlike the previous ones. But why is the motor operating at full speed and the LEDs on at full brightness? This is because the NPN transistor is controlling a larger current due to another one that flows into the transistor. A small electric current flowing into the transistor through the selector controls a larger current that flows into the transistor via the disco motor. And so the NPN acts like an amplifier, which makes the current stronger and allows the motor to work properly. Project 147 is Selector with Disco Ball and PNP. This circuit has a similar principle as the previous one, however we are using the PNP transistor instead of the NPN one, and so the current will flow through it in the opposite direction. The slide switch is already on, and we will now push each of the buttons on the S8 module. The disco motor and lights are all at full power. And like in the previous project, the transistor is amplifying the current so that it is stronger. It's just working in the opposite direction. 148 is slower and dimmer disco. I am going to turn on the slide switch, and the disco motor spins and lights up. However, it's not as fast or bright as in Project 10, for example. And when you push the press switch, the disco motor will spin faster at full speed, but the LEDs will be off completely. Now, the reason why the disco motor does not operate at full power in this circuit is because the LEDs are connected in series with the motor, not in parallel. When you connect parts in series, you're reducing power to them, however, the battery life will be longer. If the LEDs were in parallel, they would be brighter, but battery life will be shorter. The way these jumper wires are hooked up, they are in series. In this case, if one LED was to fail, the rest would fail too. Project 149 is Selector with word fan. Now you'll see that this project does not have any switches, just the S8 module. What we will do is push any of the buttons here, and the programmable fan will spin and display the messages. It should cycle through all of them. I'm just going to hold the button down long enough for the second message to appear, which is my name. Because if I let go of the button and the motor stops, it will reset itself. Yep, there's my name right there. Now, releasing the button and pushing another one will not do anything. The operation of the motor will be the same. The selector, in this circuit, the selector cannot control the programmable fan directly. So therefore we use the NPN transistor to help. A small electric current which flows into the transistor will control a larger current that flows into it via the programmable fan. Project 150 is Select the Fan. This circuit looks very similar to the previous one, but I did change the direction of the programmable fan. So, when I hold down any of the buttons on the selector module, the fan will rotate in the opposite direction, but it will not light up because current can flow through LEDs only in one direction, and therefore the motor will not light up. The blades will not light up in both directions. Project 151 is Word Fan PNP. I'm using the PNP transistor instead of the NPN one with the fan, and I'm going to hit one of the following buttons on the S8 module. First I need to turn on the slide switch. But you have to be careful not to bend the blades of the programmable fan because they have complicated technology in them. These are the LEDs, by the way. Hold the button down and the disco and the programmable fan spins and lights up. Like what I said before, the PNP and NPN transistors are similar, but the current will flow through them in opposite directions. And now I'm just going to move right to Project 152, which involves simply reversing the motor and holding down one of the buttons. The motor will spin at full speed, but it will not light up due to the direction it is connected. The current cannot flow through the LEDs in the opposite direction. Project 153 is Bicolor Swing Circuit. Now this project is very interesting. You'll notice that two of the double snap wires are not connected. That is because you can connect them to one of two sets of points. Here are the point A points, and then here are the point B points. The A points, B points. I am going to connect. Let's see what happens when we connect this wire, the wires to the A points. The bicolor LED comes on and it is yellow. That is because current is flowing through the LED in this direction. Now I am going to switch the wires so that they now connect to the B points. Although it may be hard to notice the difference in color, the red LED is on and the yellow LED is off. That's because the current is now flowing in this direction. Project 154 is adjusting disco cover focus. This is one of at least 3 projects in which I will be able to use either the disco covers without the shaft. I will be holding them above the disco motor. For this project, we're going to turn off this light and then turn on the slide switch. Now the LEDs on the disco motor will light up completely, but the motor will not spin. I am going to point the camera at the ceiling and hold the disco cover over the motor. And you can see the spectacular pattern on the ceiling. Kind of looks like gears or stars. You can turn the cover around, although it's very hard to do so with one hand, with your hand, without it getting in the way. But just to give you an idea, you can also raise and lower the cover like I am doing. And it's very fun to watch the pattern change. The closer the motor is to the lights, the larger the patterns will be. Now the bigger cover has hexagon-like shapes, and if you lower it very close, like maybe only 2 inches from the motor, which is about the height the shaft is, you will see the patterns will become larger. Or actually smaller, but they're more clear. And then you can twist the cover around. Project 155 is called Diffused Light. It's hard to say, but I'm using the same circuit as in the previous project, but I removed the disco motor, and you're supposed to put one of the 3 main LEDs in across certain points. Now, I'm going to turn this light on so you can see. I removed the disco motor, but I put the red LED, in this case, right here. And then I can put one of the covers over and see what kind of pattern it will produce on the ceiling. And what do you see? You don't see anything because of how dim the red LED is, and it's even dimmer than the red light on the disco motor. But you can switch the LEDs, and I am going to try to use another one. Alright, here we have the bicolor LED, and it is now yellow. It's considerably brighter, and maybe hard to, for the camera may not pick it up, but there is a faint pattern on the ceiling. It gets larger when you lower the cover, but I don't know if the camera picks it up. Now I am inserting the red LED, and rotating the bicolor LED so that the red one is on, but once again the pattern is barely visible. Lastly, I'm going to try the green LED. Now we have the green LED, and it's not as bright. The pattern is very faint, so to conclude, this these LEDs are not too bright, and therefore they produce very faint ceiling patterns, which my phone does not pick up. Project 156 is your light patterns. This project does not require you to build a circuit, but you would need a flashlight in your home, whether it's incandescent or LED. Unfortunately, I can't do this project because even though I tried it with the curtains closed in this room, the light did not seem to project onto the ceiling. But what you would do is hold one of the disco covers over the light and then spin it and look up at the ceiling and see what it does. And you could adjust the height of the cover above the light to get a better idea of whether to see how the pattern changes. You could try it with both an incandescent light bulb flashlight and, if you have one, an LED one. Here's what Mr. Snappy is saying. The results will depend on the light source used, but LEDs will give better patterns than incandescent light bulbs since their light tends to be more focused forward, unlike incandescent light bulbs in which the light is scattered in all directions. Alternatively, you could aim the lamp at a wall or other vertical flat surface. But the ceiling is best because when I tried it vertically, it was difficult to mount the light and hold the disco motor at the same time. Project 157 is pressure circuit. This is the circuit here, and what you would do is place your finger on point A to complete the circuit. When I do so, the red LED turns on. When I let go of the 5-snap wire, the LED turns off. The reason why you have to hold the 5-snap wire down in the middle is because the 5-snap and 3-snap wires are not actually touching. It may appear that they are, but you have to hold down the 5-snap wire in order to make a complete circuit and turn on the LED. Project 158 is PNP Transistor. This project will show the main principle of the PNP or Q1 transistor. Now, I have explained the principle of both the PNP and NPN transistors in numerous other projects, but here they give you a much more basic example of how it works. We will turn on the slide switch and nothing happens. I will then hold down the press switch and the red LED will come on, but the green LED will stay off. I'm going to hit the S2 switch again. Only the red LED comes on. Transistors use small electric currents to control larger currents. In this scenario, pressing the S2 switch will make a small current flow out of the PNP transistor through the green LED, which will then trigger a large current out of the transistor through the red LED. Now, actually, the green LED does come on. I didn't know that. But it is so dim that it may appear to be off, even in a dark room. So technically it's on, but you don't really see it. Project 159 is NPN Transistor. Now we are using the NPN transistor, and I am going to push the press switch. The red LED comes on, and so does the green LED, but once again it's so dim that it appears to be off, and you may not be able to see it even in a dark room. In this scenario, the current is flowing through the NPN transistor in the opposite direction. the NPN transistor is essentially the same as the PNP one, but when you push the S2 switch in this project, a small current will flow into the transistor through the green LED, which will trigger a large current into the transistor via the red LED.